The process of crafting a church bell begins with the meticulous preparation of the mold, an essential step in determining the bell's shape and structural integrity. Powdered clay, the primary material, is carefully sifted through a fine sieve to remove any impurities, ensuring a uniform, fine texture. This ensures the final mold is free from inconsistencies that could affect its durability or the clarity of the bell's sound. Once the clay is refined, husk is added to it. The husk plays a dual role, acting as a binding agent while providing flexibility to the mixture. The combined materials are kneaded thoroughly, creating a pliable, dough-like consistency. This careful kneading ensures that the mixture is evenly distributed and ready for application. The prepared clay mixture is then applied to a specialized tool called Narrowson. This tool resembles a rolling pin, with both ends secured by bush bearings. These bearings allow the Narrowson to rotate smoothly and evenly during the application process. The clay is carefully layered onto the Narrowson, forming the foundation of the mold. Once molded, the clay is left to dry in natural sunlight for 24 hours. The drying process is repeated for additional layers to achieve the required dimensions. These layers, when fully dried, form the mold structure, setting the stage for the next steps. The second stage of bell making focuses on reinforcing and smoothing the mold, a critical process to ensure the structure's durability and precision. After the initial mold has dried thoroughly, internal supports are strategically placed. These supports, whose dimensions depend on the bell's size, are crucial for maintaining the mold's stability and shape during the intensive casting process. Following this, the mold undergoes further drying under natural sunlight for 2 to 3 days. This gradual drying hardens the clay, preparing it for the application of strengthening materials. During this time, black sand is heated and carefully pounded into a fine powder, which is then sifted to remove impurities. This processed sand is mixed with cow dung, burnt soil, and clay, creating a paste with excellent binding and structural properties. Water is added to achieve a smooth, workable consistency. This malleable paste is applied to the exterior of the mold, forming a protective layer. The mold is left to dry for an additional day, after which any irregularities on the surface are leveled using a sharp metal frame. To further enhance durability and prevent cracking, additional layers of finely ground cow dung, burnt soil, and clay are applied, ensuring the mold's robustness and readiness for the next stages. Once the exterior is hardened and smooth, wax is applied. This step involves the preparation of a wax mixture, made by melting wax, castor oil, and other natural products over a wood fire. The molten wax is filtered through fine cloth into water, which prevents it from sticking. The filtered wax is kneaded into circular flakes, ready for application. The wax is pasted uniformly over the mold. A red-hot rod is used to shape the wax layer to the exact contour of the bell. The rod's heat ensures that the wax adheres closely to the mold, creating a precise shape. The quantity of wax used depends on the bell's size, with larger bells requiring proportionally more wax. For instance, a 30-kilogram bell typically requires 3 kilograms of wax. Polishing the surface of the mold is a process that ensures the bell achieves a flawless finish, crucial for both its appearance and sound quality. After the wax layer has been applied and shaped, the mold's surface may have uneven textures or rough patches. To address this, artisans turn to an unconventional yet effective tool, a simple glass bottle. This traditional method, passed down through generations, remains an integral part of the craft, preserving the authenticity and heritage of the bell-making process. The mold is mounted on a rotating device to facilitate consistent polishing. As the mold rotates rapidly, the artisan presses the glass bottle firmly against its surface, working methodically from top to bottom. The smooth surface of the bottle, combined with the rotational movement, evens out irregularities and creates a polished, gleaming finish. Despite advancements in modern technology, this age-old technique is preferred for its precision and its connection to the craft's historic roots. Once the wax-coated mold is polished, a new layer of reinforcement is added. A paste is prepared using burnt soil, cow dung, and clay, mixed and ground to a smooth consistency. This mixture is carefully applied to the polished mold, creating a thin, even coating that eliminates any residual imperfections. The final layer not only refines the mold's surface but also enhances its strength, ensuring it can withstand the intense heat and pressure of the casting process. After applying the paste, the mold is left to dry under sunlight for 2 days. This slow drying process allows the outer layer to harden completely, finalizing the mold's preparation. The final stage of mold preparation is crucial to ensure the mold's durability and precision, as it must endure the intense heat and pressure of the metal casting process. This stage begins with the preparation of a fine soil paste. Fine soil is sifted meticulously to remove impurities, then ground and mixed with water to create a smooth, malleable consistency. This carefully prepared paste is applied evenly over the mold in a 1-inch thick layer, providing an additional barrier to strengthen the mold's structure. To further reinforce the mold, broken pieces of earthen pots are pressed firmly into the freshly applied paste. These shards, arranged closely and securely, form a robust framework around the mold. The use of earthen pot fragments is a traditional technique that ensures the mold can withstand the extreme conditions of the molten metal pour without cracking or losing its shape. The mold, now reinforced and coated, is left to dry naturally under sunlight for 3 days. This extended drying period allows the outer layer to harden thoroughly, creating a rigid and resilient shell. Sunlight plays a vital role in achieving a uniform hardness, as it eliminates any residual moisture that could compromise the mold during casting. Once the drying is complete, the mold is placed on a cushion-like base to prepare it for the next stage. The bottom of the mold rests securely on this base, providing stability, while the Narrowson arm, which was essential during the shaping phase, is carefully removed. This step marks the mold's readiness for the casting process. Preparing the mold for casting is a process that ensures the mold is strong and resilient enough to withstand the high temperatures and pressure of molten metal. This stage begins with the dried mold, which has already been shaped into the form of a bell. The mold is inverted so that its interior faces upward, exposing it directly to sunlight. This ensures that the interior dries completely, removing any residual moisture that might weaken the mold during casting. To protect the mold from cracking under extreme heat, an iron strip is carefully wrapped around its exterior. This reinforcement prevents structural weaknesses and ensures that the mold retains its integrity during the critical casting stage. Next, a layer of soil paste is applied over the entire mold. This paste is made by mixing fine soil with water to create a thick, cohesive substance. The paste is applied to a thickness of approximately 2 inches, adding another layer of protection against thermal stress. Once the paste is applied, the mold is left to dry naturally under direct sunlight for 5 days. This slow drying process ensures the additional layer hardens uniformly, further enhancing the mold's durability. After this drying period, the mold is turned upright, revealing its bell-like shape. This is a crucial moment in the process, as it confirms that the mold has achieved its intended form and is now structurally complete. The mold is then carefully placed into a prepared pit, which is lined with a small brick wall to provide support and containment during the next steps. Firewood is arranged around the mold in the pit and ignited to generate consistent heat. As the fire burns, the wax inside the mold begins to melt. For a mold designed to produce a 30 kilograms bell, approximately 3 kilograms of wax is used. During this process, most of the wax liquefies and flows out of the mold, while the remaining wax burns off, converting into vapor. This step not only removes the wax, but also leaves a precise cavity within the mold, perfectly shaped for the molten bronze that will soon be poured. The process of melting and pouring the metal is one of the most critical stages in bell making, requiring precision and careful handling. The bronze used for casting the bell is an alloy composed of copper, tin, and zinc, mixed in the specific ratio of 75:22:3. These metals are chosen for their combined strength, malleability, and tonal qualities, which contribute to the bell's durability and resonance. The metals are broken into small, manageable pieces and divided among melting pots. For instance, in the production of a 30 kilograms bell, 2 melting pots are used, each holding 15 kilograms of metal bits. The pots are covered with a layer of soft sand, which acts as insulation to maintain consistent heat distribution. These pots are then placed inside a specially constructed furnace made from bricks and earth. Charcoal is added as the primary fuel source for the furnace, and a blower is attached to ensure a steady supply of oxygen. This airflow intensifies the heat, allowing the furnace to reach the high temperatures needed to melt the metals. Over approximately 3 hours, the metals transform into a homogeneous liquid bronze, ready for casting. Simultaneously, the prepared mold is placed in a pit lined with wet soil. This careful placement provides stability and ensures even heat dissipation during the casting process. The wet soil also acts as a cushion, protecting the mold from cracking under the intense heat of the molten bronze. When the bronze is fully molten, the melting pots are carefully removed from the furnace using long-handled pliers. The liquid metal is then poured into the mold through designated openings called runners. Breaking the mold and finishing the bell after cooling, the mold is carefully removed from the pit. It is broken apart using a cutting iron and hammer, and the reinforcing iron strip is taken off. Residual soil patches are cleaned from the bell with specialized tools. The raw bell undergoes multiple rounds of polishing. Initially, a wet stone attached to a motor is used to remove any rough edges or bristles. The surface is further refined using emery paper of varying grades, 60, 80, and 120. A final polish with an emery mop imparts the bell with a golden shine, ensuring a visually striking finish. The bell's sound quality and resonance are carefully measured. The weight of the bell significantly influences its range. For instance, a 100 kilograms bell can carry its sound up to 1 kilometer in quiet surroundings and up to 2 kilometers in ideal acoustic conditions. The bell's shape and height are also critical, with the height typically being 10% less than the rim diameter. This bell-making tradition, rooted in precision and quality, has garnered international recognition. Bells ranging from 30 to 1,000 kilograms have been crafted, with prices varying between 25,000 rupees and 400,000 rupees. Notable achievements include the export of bells to Africa, Malaysia, Singapore, and even England, fulfilling dreams of taking Indian craftsmanship to a global stage.
The process of hand casting a Swiss cowbell, specifically in the Glock style, is a detailed and intricate art reflecting both tradition and craftsmanship. At Glockengießerei Gusset, this process begins with the selection and preparation of the model and continues through multiple precise stages until the final product is polished and ready for use. Molding the outer piece, the journey starts with the choice of a bell model. In the workshop, the model is formed using quartz containing natural sand. This sand is prepared without any chemical additives, using only water to achieve the right consistency. Depending on the chosen bell model, a suitable 2-part mold box is selected and dusted with talcum powder to prevent the damp sand from adhering to the model. The larger part of the mold box is placed over the model, and sand is gradually filled in. As the mold nears completion, the clapper is inserted into a recess at the top of the model. This clapper will later facilitate the attachment of the desired strap. Molding the core piece is then molded using a core support to ensure that it does not collapse into the outer piece during casting. The smaller part of the mold box is placed on top, completing the bell mold. After the bell is fully molded, a pour spout and casting channels are created, extending to the inside of the model. The 2-part mold box is then carefully separated to allow for the next stage, inscription. Inscribing the bell is a delicate process involving various stamps that are pressed carefully into the sand. Customers can order custom stamps to personalize their bells with specific text or designs tailored to different occasions or preferences. This step ensures that each bell carries unique and individual characteristics. Casting the bell is a crucial and precise phase in the bell making process, demanding both expertise and careful timing. In the early hours of the morning, the smelting furnace is ignited, signaling the start of this intricate process. The furnace is tasked with melting the bell metal, a meticulously chosen alloy composed of 80% copper and 20% tin. This specific composition is essential for achieving the desired acoustic properties and durability of the bell. As the temperature inside the furnace steadily rises, it reaches approximately 1,280 degrees Celsius, 2,336 degrees Fahrenheit, the optimal point for the metal to become fully molten and ready for casting. This stage requires constant monitoring to ensure the temperature remains stable, preventing any imperfections in the alloy that could affect the bell's quality. Once the metal has reached the desired temperature, the molten alloy is carefully poured into the prepared sand mold. This step must be executed with precision to ensure the metal flows evenly into all parts of the mold, filling every intricate detail of the design. The process of pouring the metal is both an art and a science, requiring a steady hand and a keen eye. After the mold is filled, the metal must cool and solidify, which typically takes about 15 to 20 minutes. This cooling period is critical, as it allows the metal to set properly, forming the final shape of the bell. During this time, the furnace is efficiently refilled with copper, utilizing the residual heat to prepare for future castings. This practice not only conserves energy but also maintains the furnace's readiness for subsequent batches, ensuring a smooth and continuous production process. After the cooling period, the bell is ready to be removed from the sand mold. This step involves breaking the pour channels and extracting the bell. Knowing that each sand mold can only be used once and is destroyed during this process, the final stage is the finishing process. The bell is aligned and the clapper is carefully adjusted using a spirit level and precise manual adjustments. Sound bowl casting for Tirol Wurbung, Grasmere Bell Foundry. Matthias Prachensky, copyright 2014. The 2014 project, Sound Bowl Casting for Tirol Wurbung, is a captivating collaboration between the renowned Grasmere Bell Foundry and the creative vision of Matthias Prachensky. This project is a unique fusion of traditional craftsmanship and modern artistry, aimed at promoting the Tyrol region through an evocative and sensory-rich medium. Grasmere Bell Foundry. The Grasmere Bell Foundry, located in Innsbruck, Austria, is one of the oldest family-run businesses in Europe, with over 400 years of history in bell making. The foundry is celebrated for its craftsmanship and the high quality of its bells, which are known for their exceptional sound. Their expertise extends beyond traditional bell making to creating intricate sound bowls, which are used in various cultural and therapeutic contexts for their resonant and soothing tones. Matthias Prachensky and Dikulis. Matthias Prachensky, an artist known for his innovative approach to visual and auditory experiences, collaborated with Grasmere for this project. His company, Dikulis, specializes in creating immersive environments that blend film, photography, and sound. Prachensky's involvement ensured that the project was not only about creating a beautiful object, but also about crafting an experience that could engage and inspire audiences. The creation process, the casting of the sound bowls, was a planned and executed process, captured in high-definition film to highlight the artistry involved. The process begins with designing the sound bowl, considering both aesthetic appeal and acoustic properties. Molten metal is then poured into molds, and once the metal cools and hardens, the bowls are carefully polished and tuned to produce the desired sound. Founded over 400 years ago in Innsbruck, the Grasmere Bell Foundry is a historic institution and one of the largest bell manufacturers in the world. As Austria's oldest family business, Grasmere has crafted bells that resonate in more than 100 countries and serve 8 different religions, a testament to its unparalleled expertise and global reach. The intricate bell-making process begins with constructing the core, the heart of the bell. Once the core is in place, skilled workers apply layers of clay over it, carefully shaping each layer to achieve the precise geometry of the bell. This step is vital for ensuring the structural accuracy and integrity of the final product. Artistry plays a crucial role in the next phase. Talented artists carve elaborate designs into the clay surface. These designs are then filled with molten wax, which solidifies to capture the intricate details. This wax model must be flawless, as any imperfections will be directly transferred to the final bell. The engraving of the wax requires exceptional skill and precision, as even the smallest mistake can affect the quality and aesthetics of the bell. In some instances, the wax model is coated with a thin layer of clay and then baked, forming a hard and durable ceramic shell. Inside the Grasmere Bell Foundry, the bell-making process is supported by a variety of advanced furnaces, which are critical for achieving the precise temperatures required for melting the metal alloy used in bell production. Among these, gas-fired furnaces play a significant role, utilizing natural gas or propane as a fuel source. These furnaces are equipped with specialized burners that mix the gas with air, producing a powerful flame capable of generating the immense heat necessary for melting the bronze alloy. The alloy used by Grasmere to produce their renowned bronze bells consists of 80% copper and 20% tin. This specific composition is essential for creating bells with the desired acoustic properties and durability. To melt this alloy, the furnaces are heated to approximately 2000 degrees Fahrenheit. Achieving and maintaining this temperature requires careful monitoring and control, as any deviations can adversely affect the quality of the final product. Modern tools, such as temperature profiles and computer simulations, are employed to ensure that the temperature remains consistent and optimal throughout the melting process. Worker safety is a top priority at Grasmere, particularly when dealing with the extreme temperatures involved in bell casting. Foundry workers wear protective clothing made from aluminized fabrics, which are designed to reflect up to 95% of radiant energy. This aluminum layer is crucial for protecting workers against the intense heat and potential molten metal splashes. The protective clothing not only prevents burns, but also helps maintain a safe working environment during the high-risk melting and pouring stages. The use of crucibles is another important aspect of the bell casting process. These containers are specifically designed to withstand the high temperatures required to melt the bronze alloy. Crucibles must be made from materials that can endure prolonged exposure to extreme heat without degrading, ensuring that the molten metal remains pure and free from contaminants. Once the metal is melted, the precise control of temperature becomes even more critical. Underheating can result in an incomplete mix of copper and tin, leading to poor mechanical properties and a bell that lacks the desired acoustic quality. Overheating, on the other hand, can cause the formation of oxides, which can weaken the structure of the bell and adversely affect its sound. Therefore, maintaining the correct temperature is essential for ensuring a uniform mix and the desired mechanical properties. The acoustic properties of a bell are highly dependent on the composition and structure of the material. Even slight variations in the alloy mix or the cooling process can significantly impact the bell's sound quality. Grasmere's commitment to research and development has led to the integration of advanced technologies that aid in controlling and perfecting these variables. By using temperature profiles and computer simulations, Grasmere can predict and adjust the outcomes of the casting process, ensuring each bell meets their high standards of excellence. The bell casting process at Grasmere Bell Foundry includes meticulous preparations before pouring the molten metal. One critical step is preheating the molds. This procedure is essential to prevent thermal shock, which can occur if hot metal is poured into a cold mold. Thermal shock can cause cracks and other structural defects in the bell, compromising its integrity and sound quality. By preheating the molds, the foundry ensures a more gradual and controlled transition of temperatures, promoting a smooth casting process. During the pouring process, ensuring a constant flow of molten metal is crucial. Workers use various tools, including ladles, to scoop and pour the metal. This careful handling is vital to fill all the intricate gaps within the mold consistently and completely. The ladles, designed to withstand high temperatures, allow workers to manage the flow rate accurately, ensuring that the metal fills the mold evenly without leaving any voids or air pockets that could weaken the bell. Accurate calculations made prior to pouring are essential for determining the exact quantity of metal required. These calculations account for the bell's size, shape, and intricate details, ensuring that there is enough molten metal to completely fill the mold. Any shortage could result in incomplete casting, while excess metal can lead to waste and potential flaws in the final product. Once the molten metal has been poured and allowed to cool, the bell is carefully removed from the mold. At this stage, it undergoes a thorough cleaning process to eliminate any remaining mold material and surface imperfections. This step is particularly crucial around decorative areas, where intricate designs must be preserved and refined. Cleaning ensures that the bell's surface is smooth and free from any residues that could affect its appearance and sound quality. The cooling process is another critical phase that can last several days or even weeks, depending on the bell's size and complexity. Slow cooling is essential to prevent cracking and other types of damage that can occur if the metal cools too quickly. Controlled cooling allows the metal to solidify evenly, reducing internal stresses and ensuring the bell's durability and structural integrity. Finally, the bell undergoes acoustic testing using advanced software. This software analyzes the bell's sound frequencies, ensuring they fall within acceptable ranges. Precise tuning is performed to achieve the desired tonal qualities, making each bell not only a piece of art but also an instrument of superior acoustic performance. Grassmayer's dedication to detail and quality at every step of the process ensures that each bell meets the highest standards of craftsmanship and sound.